You close the vent in the spare bedroom, give the little lever a firm push, and figure you've just done something sensible. One less room burning your energy dollars. Logical, practical, and almost entirely wrong. I have been paying attention to how HVAC systems behave for a long time, watching what holds up, what fails, and why. And the vent closing habit is one of those things that feels so obviously right that almost nobody questions it. I used to half believe it myself, until I started connecting the dots between that innocent little habit and some expensive repair bills that did not have to happen. Here's what nobody in the business has much reason to tell you. Closing your supply vents does not stop your HVAC system from working. It just makes the work harder, the wear faster, and the damage quieter. The kind that builds up slowly until one summer afternoon your system stops cooling and you are looking at a serious repair bill. The idea that you can cut your energy use by blocking off rooms is one of those pieces of folk wisdom that sounds right but breaks down the moment you understand how these systems actually move air. If you want to go deeper on HVAC health and home efficiency than I can cover in one video, our guide is for you. The QR code is right there on the left side of the screen. Open your phone's camera app and point it at that code right now to get the guide. It covers a lot more ground than we can touch on here. And that same QR code is now staying pinned in the top right corner of your screen for the rest of the video, so you can scan it anytime later without pausing. Open your camera app, point it at the top right corner, and it takes you right there. Now let me walk you through exactly what is happening inside that ductwork when you close a vent, because once you see it, you cannot unsee it. Your HVAC system is designed as a balanced, pressurized loop. The blower motor at the center of your system is sized for a specific volume of airflow. Whoever designed and installed that system, whether they did a good job or a rushed one, built it around a certain number of supply vents open and a certain number of return vents open. Air flows out through the supply registers, circulates through the living space, gets pulled back through the return registers, passes over the evaporator coil or the heat exchanger, gets conditioned again, and goes back around. The pressure inside the ductwork stays within the range the system was built for. The blower runs at its intended load. Everything holds together. The moment you close a vent, you block one of the exits. The blower does not know that. It is still trying to push the same volume of air it always does. That air has to go somewhere, and with a register blocked, pressure builds inside the duct system. Pressurized ductwork, especially in homes built before the late 1980s and into the 1990s, is almost never perfectly sealed. There are seams, joints, boots, and connections throughout, and a lot of them have gaps. When internal pressure rises, the air finds those gaps and pushes through them. Air that was supposed to reach your living rooms ends up in the attic, and then losing it before it ever does any useful work. Closing a vent does not keep that air in the system, it leaks it out somewhere worse. There is a mechanical problem layered on top of that, and this is the one I think about the most. When internal duct pressure climbs too high, the blower motor has to work harder to push air through the system. It draws more electricity. It runs hotter. It cycles under more strain. Blower motors are durable pieces of equipment, and but I have seen them wear out well ahead of schedule. And when you trace it back, the pattern often includes years of partially closed duct systems. You cannot see that damage accumulating. It just quietly takes years off the life of a central air system or a heat pump. There is another layer of risk that is worth understanding clearly. When static pressure goes up, airflow over your evaporator coil slows down. That coil is the part of your AC that actually absorbs heat from your home's air. It relies on a steady, sufficient volume of air moving across its surface. When airflow drops, The coil gets colder than it should. It can ice over. A frozen evaporator coil cannot do. The system loses its ability to cool. If you keep running it that way, the compressor starts working against conditions it was never built for. Compressor failure is one of the more expensive repairs in residential HVAC. Depending on your system, that repair can run from several $100s well into the thousands. That is a hard lesson to learn from something as small as closing a few vents. Now let me push back on the specific you're not using. The reasoning makes intuitive sense. Why heat or cool a room nobody is in? But your HVAC system does not work like a garden hose where you put your thumb over part of the nozzle and less water flows. It works like a pressurized loop with a pump that is always moving the same volume. Blocking part of the output does not reduce the load. It redirects the stress into parts of the system. In summer, a room you have closed off and stopped cooling does not just sit there quietly. Especially on an upper floor or in a room with a lot of south or west-facing glass, that room absorbs heat all day. Heat moves toward cooler spaces. That is physics, not opinion. So that uncooled room radiates warmth into the hallway, into adjacent bedrooms, into the living space. The thermostat picks up on that warmth and calls for more cooling. The system runs longer cycles to compensate. Your energy bill goes up, even though you closed a room. The savings you were counting on evaporate, and the equipment wear is still happening underneath it all. If you want to go further on what we just covered, the pressure dynamics, the coil risk, the way heat moves through a house, the guide goes into more depth on all of this than I can here in one video. Open your camera app and point it at the QR code in the top right corner of the screen. It is still there. That is what it is for. The fuller picture when you want it. So what should you actually do if you want to condition different parts of your home at different levels? The right tool for that job is a zoning system. These use motorized dampers installed inside the ductwork itself, controlled by multiple thermostats, one for each zone you define. When one zone reaches its target temperature, its damper partially closes in a controlled, engineered way that the system accounts for. The blower and the controls work together to keep static pressure within safe limits. It is not a weekend project, and it is not free, but it is the proper engineering solution to the problem. A qualified HVAC technician can tell you whether your existing ductwork can support a zoning setup and give you a realistic number for your home. For most folks, though, the most immediate and affordable step is simpler. Open your vents, all of them. Let the system breathe the way it was designed to breathe. Beyond that, there are a few things worth checking that cost nothing or very little. Start with your return vents. A lot of homes, especially those built a few decades back, were built with too few return registers. When returns are undersized or blocked, the system cannot pull air back efficiently, and pressure imbalance follows. Walk through your home and make sure every return vent is clear. Furniture pushed in front of a return register is one of the most common and most overlooked problems in residential HVAC. Move the couch. Move the bookcase. That costs you nothing. Check your air filter too. A clogged filter restricts airflow on the intake side almost as effectively as closing vents does, and it is something that slides off the to-do list when life gets busy. Depending on the type of filter and the conditions in your home, you likely need a fresh one every 1 to 3 months. Pull it out and look at it. If it is gray and matted, replace it today. If you have rooms that are persistently uncomfortable, too warm in summer, too cold in winter, talk to an HVAC technician about airflow balancing. A good technician can actually measure the airflow at each register, identify which rooms are getting too much or too little, and make adjustments inside the duct system to redistribute it properly. This is the engineered version of what people try to do by hand when they close vents, and it works without punishing the equipment. The cost for a balancing visit is typically modest compared to compressor or blower motor repair. And here is the longer-term piece that I think is genuinely underrated. If you want to take real pressure off your HVAC system and reduce what it costs to run, the most durable answer is insulation and air sealing, not vent closing. A room with good insulation in the walls, ceiling, and around windows holds its temperature far longer on its own. Your HVAC system does not have to work as hard to maintain comfort throughout the house. That spare bedroom stays closer to the right temperature without the system running to keep up. That is the old, patient approach to the problem. The one that takes more effort up front, but pays you back year after year without wearing out your equipment. Everything we have covered today, the pressure buildup, the coil risk, the balanced return system, the proper alternatives, is the kind of foundation that lets you take real care of something you have spent significant money on. If you want to keep going on any of it, open your camera app and scan the QR code in the top right corner of the screen. The guide goes deeper into the material and gives you something to come back to when you need it. So here is what I want you to do with this. This week, go through your home and open every supply vent and every return vent. While you are at it, pull your filter and check it. Next month, if you are still dealing with uneven temperatures or higher bills than you expect, call a qualified HVAC technician for a diagnostic visit. Not a sales call, a diagnostic. Ask them specifically about static pressure and whether your ducts have significant leaks. Those two questions will tell you a lot about the state of your system. There is no gadget to sell you here, no vent deflector, no magic register cover, no device that makes closing a vent safe. The fix is to stop doing the thing that is causing the problem. Your system was engineered with every vent open. Honor that, and it will serve you reliably for years longer than it otherwise would. If you have been closing vents for years, maybe you were told to, maybe it just seemed logical, drop a comment below and tell me which rooms. And if you learned this lesson the hard way after a repair bill, share that too. Your experience might save someone else from the same mistake. If you are not subscribed yet and this kind of plain, practical home knowledge is useful to you, we would love to have you stick around. We cover it straight, without the sales pitch. Coming up next, we are going to dig into what HVAC filter ratings actually mean and which ones are genuinely worth the extra cost. And the answer there surprises a lot of folks too.